Hello everyone. This session is regarding transformers, which is a topic from 4th module. Transformers. Transformer is one of the most useful electrical device ever invented. It can change the magnitude of alternating voltage or current from one value to another. It have no moving parts, so it is having high efficiency, and hence transformers are known as static device. It transfers alternating electrical power from one circuit to another at same frequency. A transformer is a static piece of equipment used either for raising or lowering the voltage of an AC supply with a corresponding decrease or increase in current. It essentially consists of two windings, the primary and secondary, wound over a common laminated core. The basic principle behind working of transformer is principle of electromagnetic induction. When an alternating voltage V1 is applied to the primary, an alternating flux phi is set up in the core. This alternating flux links both the windings and induces EMF E1 and E2 in primary and secondary windings, according to Faraday's laws of electromagnetic induction. E1 is termed as primary EMF and E2 is termed as secondary EMF. And according to Faraday's law, E1 will be equal to minus N1 into d phi by dt and E2 equal to minus N2 into d phi by dt. So from these two equations, we can write E2 by E1 equal to N2 by N1. So if N2 is greater than N1, E2 will be greater than E1. Hence, it is known as a step-up transformer. Similarly, if N2 less than N1, secondary induced EMF E2 will be less than primary induced EMF E1. Then it is a step-down transformer. If load is connected across the secondary winding, the secondary induced EMF E2 will cause a current I2. I2 will flow through the load. Thus, a transformer enables us to transfer AC power from one circuit to another. Transfers electrical power from primary circuit to secondary circuit. It will help us to transfer AC power from one circuit to another with a change in voltage level or with a change in current level. Then EMF equation of a transformer. A voltage V1 of frequency F Hz is applied to primary. The sinusoidal flux phi produced by primary can be represented as phi is equal to phi m sin omega t. The instantaneous EMF E1 induced in the primary is E1 is equal to minus N1 d phi by dt. This is equal to minus N1 d by dt of phi is phi m sin omega t. This is equal to minus N1 omega phi m cos omega t. That is equal to minus N1 omega phi m cos minus cos omega t is plus sine omega t minus 90 degrees. Hence, it is clear that induced EMF in the primary will lag the flux by an angle 90 degrees. Now, maximum value of induced EMF E1 is maximum value of induced EMF, which is E1, will be N1 phi m omega. That is equal to omega is 2 pi f N1 phi m, which is the maximum value of induced EMF. And RMS value of induced EMF is, this is maximum, E1 max. Then RMS value of E1 is, divide the maximum value by root 2. So 2 pi divide by root 2 f n1 phi m. That is 4.44 f n1 phi m. This is the RMS value of primary induced EMF E1. Similarly, secondary induced EMF will be E2 equal to 4.44 f n2 phi m. This is known as EMF equation of a transformer. Now, from this, divide E2 and E1. We will get it as N2 by N1, which is equal to a constant K, where K is voltage transformation ratio or transformation ratio. For an ideal transformer, V2 will be equal to E2 and V1 will be equal to E1. So we can write the equation V2 by V1 equal to E2 by E1 equal to N2 by N1. Similarly, for an ideal transformer, input power, which is V1 I1, will be equal to output power V2 I2. From here we can write V2 by V1 is I1 by I2. So if we incorporate the term I2 also in the above equation, we will get the equation as V2 by V1 equal to E2 by E1 equal to N2 by N1. That is equal to I1 by I2, not I2 by I1, I1 by I2 is equal to constant K, which is the transformation ratio, voltage transformation ratio of the transformer. Okay, thank you.